Welcome. My name is Martin Litwack, a lecturer in the Mathematics and Computer Science Department at Kingsborough Community College. This video, the second in the preparation for the CUNY Elementary Algebra final exam, provides worked-out solutions for Sample B. Sample B is similar to Sample A. If you want more detail for a particular question, please refer to the same question number in Sample A. Both samples are found at the link in front of you. Your feedback is encouraged. You can email me at mlitwack@kingsborough.edu with comments and/or suggestions. Now please keep in mind that most problems in math can be solved in more than one way. The methods I've chosen here may therefore differ somewhat from those used by your instructor. This is normal and to be expected. If you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you are having difficulty with a particular problem type, this video will hopefully help you understand it better. I have solved most of the problems in one way in order to avoid confusion. Occasionally, though, I have provided more than one solution in order to more fully explain an underlying concept. Well, good luck and let's begin. Again, I encourage you to download this sample exam if you haven't already from the following link. Problem number 1 asks you to simplify the square root of 90 plus the square root of 250. What simplifying means in this problem is to see whether we can add the two square roots together, as well as whether we can simplify each square root. Now, simplifying a square root means either removing the square root altogether, such as the square root of 4, for example, which would be 2. Or if we cannot do that, which is the case here, there's no square root of 90, there's no square root of 250, making the radicand in each square root as small as possible. We want to make the 90 as small as we can, the 250 as small as we can. And the way you do that is by looking for the largest square factor, if any, in the radicand. So we'll begin by looking at the radicand, the 90. So the largest square that divides evenly into 90 is 9. So we'll rewrite 90 as 9 times 10. To that we'll add, now the largest square factor of 250 is 25, and 25 times 10 is 250. Now if you're unable to do that as quickly as I did, that's okay. You just have to try each square factor and see whether it divides evenly. So we would have tried 4, since that's 2 times 2, 2 squared. We would have tried 9, which works, etc. Now we can use the multiplication rule for square roots. What we do is we wind up putting each factor in the radicand in its own house, under its own roof. In other words, we break them up. So here we have a broken heart, and we'll put them into their own home. The square root of 9 times the square root of 10 plus the square root of 25 times the square root of 10. Well, this is looking good now, since we're going to wind up with square roots of 10. The square root of 9 is 3, so that's 3 times the square root of 10. The square root of 25 is 5, so we get 5 times the square root of 10. Now we can add these together because they're both square roots of 10. The only thing we have to determine is how many square roots of 10. Well, 3 plus 5 of them. So the final answer is 8 square roots of 10, and that is choice A. Problem 2 asks you to multiply square roots and also to divide a square root. In sample A for problem number 2, you only asked to multiply square roots. So this is a little different. I don't have enough room to write all the work for this problem, so I'll go to a separate piece of paper and we'll try it 2 different ways. We can either divide first or we can multiply first. Let's try dividing first. So the problem is the square root of 7 times the square root of 42 divided by the square root of 3. Now, just like the multiplication rule for square roots lets us multiply separate square roots and place each factor under the same roof, under the same square root, the same thing works by division. Now we see 7 is not divisible by 3, but 42 is divisible by 3. A cool way to know that is you add the digits, 4 plus 2, that's 6. Since 6 is divisible by 3, the actual number 42 is divisible by 3. So we'll marry them off. We'll put them under one roof. And the result will be the square root of 7 times the square root of 42 over 3, which is the square root of 7 times the square root of 14. Now at this point, what we do is we're going to use the multiplication rule for radicals. Basically, they're never happy. If the square roots are apart, we want to unite them, we want to marry them. If the square roots are together, if they're married, we want to divorce them. Because ultimately here we want to simplify it again. We want to make those radicands smaller. But first we have to marry them off. So we'll do this again. This time marry them again, but this time through multiplication. So we'll have them all under one square root, 7 times 14, which is the square root of 98. The largest square in 98 is 49. We'll now give them a divorce, like normal when we're simplifying square roots. Each one will get its own home. And as a result of that, we will get the square root of 49 times the square root of 2. Final answer, 7 times the square root of 2. Now we'll try multiplying first, see how that goes. I'll rewrite the problem from the beginning. So once again, we'll begin by marrying them off, marrying the square roots off, but we'll do this by multiplying. So we will get the square root of 7 times 42 divided by the square root of 3. You should probably multiply the square root of 7 times 42 on the side. Make sure you get it right. And when you do that, you get the square root of 294 divided by the square root of 3. Now we'll marry them again, this time by division. And after doing that, we'll have the square root of 294 over 3, which is equal to, once again, you should do the division on the side to make sure you get it right. 294 divided by 3 is 98. And then we're at this point over here, the same thing we did when we were dividing first. So you just move that here, and again you'll get 7 times the square root of 2. And so the final answer is going to be choice D, 7 times the square root of 2. Problem number 3 asks you to divide two numbers in scientific notation form and place the result in scientific notation form. What we first do is divide the regular decimal numbers, the 6 divided by the 8, and then we're going to divide the powers of 10, the 10 to the 3rd divided by the 10 to the 6th. Now we could perform a long division on the 6 over 8 immediately, but if we take note of the fact that we can reduce this, so 2 into 6 goes 3, 2 into 8 goes 4, and most people know that 3/4 is the same as 0.75. If you don't know that and you feel uncomfortable reducing, then you could just simply do 8 into 6, and that will give you 7, 56, 4, bring down the 0, 5. So you could do it that way as well. Either way, you get 0.75, and now you need to subtract the powers of 10 since we're dividing. So that will be 10 to the 3 minus 6 power will be negative 3. Now, if you look at the choices, that is one of the choices, but it's the wrong choice. Not because the answer that we came up with does not have the right value, but because it's the wrong form. To be in scientific notation form, the decimal part of the answer, the 0.75, must be a number between 1 and 10, greater than or equal to 1 and less than 10. So this is less than 1, so we need to figure out a way to make this at least 1. And the way we're going to do it is by moving the decimal point. So if we move the decimal point 1 here to the right, then what we're going to wind up getting is 7.5. Now remember, this number that's in the box has to be the same value, namely 0.75 that we started with. It's too big right now. So what we need to do is multiply it by a power with a negative exponent so that it becomes smaller, the size being 0.75. So we'll multiply this by 10 to the negative, and we moved it one place, 1. And we still have the 10 to the negative third that will bring down here to multiply by. So the final answer will be 7.5 times 10. Now we're adding the exponents when we multiply. So negative 1 plus negative 3 is negative 4. So 7.5 times 10 to the negative 4th is the answer, and that corresponds to choice B. Problem number 4 asks us to simplify, and they're testing our knowledge of exponents. Well, the problem starts pretty easily because whenever you have something on the top that's being multiplied and the same thing on the bottom that's being multiplied, you can cross them out. So I'm going to cross out the 2w to the thirds, and at this point I'll be left with x to the 6th over x to the negative 4. When you have a negative exponent, you can easily make it into a positive exponent. If you look at the answers, the choices, they're all positive exponents, so they want the answer to be, they want the answer to contain only positive exponents. So if you have a negative exponent in the bottom, the way you make it a positive exponent is by moving it into the numerator. So x to the negative 4th in the denominator becomes x to the positive 4th in the numerator. So x to the 6th times x to the positive 4th. And now we see we have x times itself 6 times x times itself 4 times. X is being multiplied by itself 6 plus 4, or 10 times in all. So x to the 10th is the answer. Choice A. Problem number 5 is asking you to subtract two polynomials. Now, when you do not see the coefficient of a polynomial, like it does not say here take away 2 of the polynomial or 3, So when you do not see the coefficient, it's assumed to be 1. And the 1, the negative 1, is what you can distribute. So we have 6x squared plus 7x minus 3. And now we can distribute. We have a negative 1 times negative 2x squared, which is positive 2x squared. We have negative 1 times positive 4x, which is negative 4x. And we have negative 1 times negative 5, which is positive 5. So all we have to do now is combine like terms. We have 6x squared and 2x squared. So that's 8x squared. We have positive 7x. Take away 4x, which is plus 3x. And we have negative 3 plus 5. We have 3 negatives and 5 positives, so the positives went out by 2. So the answer is 8x squared plus 3x plus 2. And that is choice B. Problem number 6 asks you to multiply two polynomials together. What we're going to have to do is distribute the 3x over the second polynomial, the negative 5 over the second polynomial, and then combine like terms. So 3x times x squared equals 3x to the third power. 3x times negative 6x equals negative 18x squared. And 3x times positive 4 equals positive 12x. Now let's distribute the negative 5. Now you could continue writing to the right over here, in this area over here, but some students like doing it vertically, and that can be easier to see. We'll line up our like terms. So negative 5 times x squared is negative 5x squared. Negative 5 times negative 6x is positive 30x. And finally, negative 5 times positive 4 is negative 20. So let's combine the terms we have in each column. So 3x to the third power. Negative 18x squared, take away 5x squared, minus 23x squared. Now you're combining like terms here, keep in mind. So you have x squareds and x squareds. You're going to have a certain number of x squareds. How many? Negative 18 plus a negative 5, negative 23x squareds are all negative, plus 42x minus 20. So the final answer is 3x to the third power minus 23x squared plus 42x minus 20, and that corresponds to choice A. Problem number 7 asks you to divide. You're asked to divide a polynomial, 3 terms, by a monomial, 1 term in the denominator. Now, one way to do this is to make 3 little fractions. And if you want to see more detail as to why we do this, you should look at sample A, problem number 7, where I go into more detail. So the 3 fractions will be 30x to the 9th divided by negative 2x to the 5th, our denominator, plus 8x to the 7th divided by our denominator, minus 2x to the 5th divided by our denominator. Now what I like to do is to determine the sign of each fraction and then cross out. Here we have a positive divided by a negative, so that will be negative. Here we have a positive divided by a negative, which will be negative. And here we have a negative divided by a negative, which will be positive. So now let's cross out. 30 over 2 is 15. And x to the 9th divided by x to the 5th. We have 9 on top. 9x is on the top. X is being multiplied by itself 9 times on the top, 5 on the bottom. 5 of them will cross out, so we'll be left with 4 of them on the top. The way that you could do that with the rule is you subtract exponents when you divide. 8 divided by 2 is 4 here. X will be the second power, subtracting the exponents when we divide. And any number divided by itself is 1. So 2x to the 5th divided by 2x to the 5th is 1. So the answer is negative 15x to the 4th minus 4x squared plus 1. And that is choice D. Problem number 8 asks you to factor completely. That usually suggests in these problems that you're going to have to factor more than once. Okay, so the first step when you're factoring is to see whether there's a GCF, a greatest common factor. That's what you want to look for first. And you look at the numbers, the coefficients. What's the largest number that divides evenly into 18 and also into 200? That will be 2. Now, if you're not sure of that, you know 2 works because both numbers are even. So 2 into 18 would go 9. 2 into 200 would be 100. So after you divide 18 by 2 and you're left with 9, you know 9 does not go into 100. You know 9 has factors of 3. 3 don't go into 100. So 2 will be the largest number that goes into 18 and 200. Now you look at the letters. What letter name is in both terms? Well, that would be x. We see y is not in the first term. And the exponent we use for the x is the lowest exponent you see in the two terms for the x. Here the x has the power of 3, here 1, so we use 1, x to the first power. And now we say to ourselves, 2x times what gives me 18x to the third? Well, 2 times 9 will give me the 18, and x times x to the second power will give me x to the third power, minus. Now 2 times what will give me 200? Well, that'll be 100. I'm just figuring out now what I need to place here inside the parentheses so when I distribute the 2x, I get what I started with. So 2x times 100 will give me 200x, but I need 200xy squared, so I need to add a y squared here. Now, usually they have this answer, or this, what we've gotten to so far is one of the choices, and you see that is choice B. So, as we saw earlier, this is right as far as a value goes, but it's wrong. The reason being, if we look more closely, we see that 9x squared minus 100y squared can be factored because it is the difference of two perfect squares. 9 is a square since it came from 3 squared. X squared sounds like a square. 100 is a square. It's 10 squared, and y squared is a square. So this can be factored. This is the difference of two squares, or two perfect squares. And the form is something minus something, something plus something. Now the first term in each factor must be the same. We want to know what times what gives me 9x squared. So that would be 3x. Similarly, the second term in each factor must be the same. We want to know what times itself gives us 100y squared. So that would be 10y, 10y. 10y times 10y is 100y squared. So that is the answer factored completely. And this corresponds to choice C. Problem number 9 asks you to factor what's called a quadratic trinomial. It's a quadratic because of the exponent of 2 here. Trinomial means 3 terms. Now there are two ways to do this when the coefficient of the x squared does not equal 1, as is the case here. So when a does not equal 1, you can use either the trial and error method to do this factoring, or you can use the AC method. Now, when I say a equals not equal or a not equal to 1, the general form of the quadratic trinomial is ax squared plus bx plus c. So let's do the trial and error method here. So what we do is we know we're going to have two binomials. So we start with 2x and x, since when multiplied together, that gives us the 2x squared. Now, the trial and error method says you need to find factors of negative 21 and try each pair. For instance, you know 7 times negative 3 equals negative 21. You know that negative 7 times 3 equals negative 21. You know 21 times negative 1 equals negative 21, etc. Instead of trying each pair to see which one makes the multiplication come out right, we can use the choices they gave us because we know one of them is correct. So let's start with choice A and see whether that is the correct choice. So they're saying we have a factor of x plus 7. Now if that's correct, then we're going to have to put a number over here such that when multiplied by positive 7 gives me negative 21, so that would be negative 3. So we know the x's come out right, the 2x squared. We know the negative 21 is right. So we have to check the x's now. So negative 3 times x is negative 3x, and 2x times 7 is positive 14x. 14x take away 3x is 11x, positive 11x, and that's what we want. So we got lucky. The first choice is the correct one, and so the final answer is choice A. Factoring using the AC method begins with finding factors of AC that add to B. Now, as we mentioned earlier, the form of a quadratic trinomial is ax squared plus bx plus c. In this case, our a is 2, so AC is going to equal 2 times our c is negative 21. So AC will equal negative 42. So we now need to do step 1. We need to find factors of negative 42 that add to 11. So we want to find factors of negative 42 that add to positive 11. Well, you may have to play around a little with it, but the answer turns out to be 14 times negative 3 equals negative 42, and 14 plus negative 3 equals positive 11. So our two numbers are 14 and negative 3. So step 2 says rewrite the x term as the sum of two terms using the terms from step 1. Well, we found 14 and negative 3, so we're going to rewrite 11x as 14x take away 3x. And we still have the minus 21. At this point, we group. So we're going to get, after grouping, we'll group the first two terms here. So then we'll look for the GCF of the first two terms, and we'll see that's 2x. So we'll take out the 2x, and we'll get x plus 7. Write a little note here. This is the GCF. And we'll repeat the x plus 7 over here. And we now need to determine what times x gives me negative 3x. Well, it'll be negative 3. And we see negative 3 times positive 7 is negative 21. So this works out. And now we finish off factoring by grouping by taking out the common binomial. And we're left with 2x minus 3. And we see this is the same answer we got before using the trial and error method.